Good afternoon, my dear students in General Chemistry 1. Welcome to this virtual class. Our topic is quantum numbers and electronic configuration. For our learning objectives, at the end of this presentation, you will be able to define the 4 quantum numbers, state the Aufbau principle, and use this principle to determine the electron configuration of an atom. State Hans' rule and apply this rule to the filling of orbitals, and use orbital filling diagrams to describe the location of electrons in an atom. And lastly, state the Pauli exclusion principle. Okay, so let us recall, kasi na-define na ito last time, what is a quantum number. So, to describe the location of any electron in an associated atom is called, we have this term quantum number. And used to specify the properties of an atomic orbitals and the electrons in those orbitals. So, an electron in an atom or ion has 4 quantum numbers to describe especially its state. So, itong quantum numbers are like addresses of electrons. No? So, merong specific location ang mga electrons sa different energy levels. So, first we have this principal quantum number. This signified by small n. And this is the main energy level occupied by the electrons. Energy levels are fixed distances from the nucleus of a given atom. They are described in terms of whole number. So recall that if we have a nucleus as the central part of the atom, nandyan yung proton at saka neutrons. So yung mga electrons nasa different levels, right. So this is our first energy level, second, and third, and say fourth. So walang electrons na mag-reside dito sa distances na to. Nandito yan sila sa orbit. Again, walang electrons na nasa spaces between energy level 1 and 2, or 2 and 3, or 3 and 4. Next is angular momentum quantum number. So signified as L, describe the general shape of a region an electron occupies, its orbital shape. Next is magnetic quantum number, signified as M sub L. So describe the orbital orientation in space. Electrons can be situated in one of 3 planes in 3-dimensional space around a given nucleus. And then the fourth quantum number is the spin quantum number. This describes the spin for a given electron. So an electron can have 1 or 2 spins. Positive 1/2 spin or negative 1/2 spin. Kasi in one orbital, okay, so let us use a square para sa ating orbital, and let us use an arrow for electrons. So, 2 electrons maximum in an orbital. And an electron cannot be 0 spin, no? We also represent spin in terms of arrows. Ito na yun. Not a single orbital can hold a maximum of 2, but then pwede yan 1. Depende sa number of electrons ng atom. Provided they have opposite spin. So next is the Aufbau principle. So in order to create ground state electron configuration for any element, it is necessary to know the way in which the atomic sublevels are organized in order of increasing order. So the lowest energy level is always the 1s subshell, which consists of one orbital. The single electron of the hydrogen atom will occupy the 1s orbital when the atom is in its ground state. So as we proceed with atoms with multiple electrons, those electrons are added to the next lowest level, 2s, 2p, 3s, and so on. So this Aufbau principle states that an electron occupies orbitals in order from lowest energy to highest. The word Aufbau or Aufbau in German meaning building up or construction. So principle is sometimes referred to building up principle. It is worth noting that in reality, atoms are not built by adding protons and electrons, one at a time, and that this method is merely an aid for us to understand the end result. So this is the diagonal rule for electron filling order. Okay. So meron itong 1s dito, tapos arrow, diagonal. Okay, so starting from 1s, ang next na ma-filled in ng electron ang 2s. Next ng 2s is 2p and then 3s. Pagkatapos ng 3s is 3p, then 4s before 3d. Because 4s has lower energy than 3d. So after 3d, we have 4p, 5s, and then 4d, 5p, 6s, and then balik sa 4f, 5d, 6p, 7s, and so on. So this is Aufbau principle. So what is this Aufbau principle? Anong statement? So ulit, this principle states that an electron occupies orbitals in order from lowest energy to highest. So meaning mauna muna mapasukan ng electron yung lowest energy. Say kung nasa subshell, lowest subshell, or lowest energy subshell, yung 1s. So for number 2, 3, and 4, we need a diagram. Ito yung diagram. Again, we have 1s and then diagonal. Okay, so mauna ang 1s, next ang 2s, 2p, 3s. I-follow lang natin itong diagonal line. No? Now, in number 2, which orbital is filled after the 2p? So ano daw ang orbital na ma-filled after 2p? So after 2p, 3s ang ma-filled ng electron. In number 3, so in number 3, which orbital is filled after 4s? So after ng 4s, we have 3d. So nauna si 4s than 3d. Kasi 4s has lower energy compared to 3d. So for number 4, which orbital is filled after 6s? So pagkatapos ng 6s, ano daw ang sunod na ma-fill in ng electron? Is 4f. Okay ba? So wala ba question? Which orbital is filled after 2p? It is 3s. Filled after 4s? After sa 4s, 3d. So after 6s, then we have 4f. That's the Aufbau principle. Okay? So electron configuration notation, eliminates the boxes and arrows of orbital filling diagram. Each occupied level designation is written followed by a superscript, where the superscript is the number of electrons in that sublevel. Superscript, no? Kung meron tayong 1s2, ang 2 ang superscript. Indicates number of electrons. Okay, for example, we have hydrogen configuration. So, hydrogen configuration is 1s1. Kasi hydrogen, yung atomic number Z of hydrogen is 1. So, yan lang ang i-distribute ng electron configuration, no? 1s1. So, itong 1 na to, yan ang 1 ng Z as number of electron ng hydrogen. So, while helium with Z equal to 2, so ang configuration niya 1s2. Okay. So, yung maximum number of electrons in S is 2. Maximum ito ha, pwede na 1. Maximum. Maximum ng P is 6. Maximum ng D is 10. Maximum number of electrons in F subshell is 14. Maximum. So, pwedeng less than 14, less than 10, less than 6, and less than 2. So, sa helium, napuno muna yung 1s. So, multiple occupied sublevels are written one after another. The electron configuration of lithium is 1s2, 2s1. So, ang lithium naman, merong 3 electrons, atomic number na 3. So, pag-distribute niyan, 1s2, maximum, magpuno muna yung 1s. And then, 2s1. So, 2 plus 1 na mga superscripts is equal to 3. Where 3 is the atomic number. Okay? So, next is the orbital filling diagram and electron configuration. So, draw the orbital filling diagram for carbon and write its electron configuration. Step 1, list the known quantities and plan the problem. So, in this case, atomic number of carbon is given to be Z equal to 6. So, use the order field diagram to draw an orbital filling diagram with a total of 6 electrons. And then follow Hans' rule, write the electron configuration. Step 2, construct the diagram. Orbital filling diagram for carbon with configuration 1s2, 2s2, and 2p2. Third is to think about your result. So following the 2s sublevel is the 2p, and p sublevels always consist of 3. So remember that pag sa p sublevels, meron yung 3 orbitals. Ang s, isa. So all 3 orbitals need to be drawn even if 1 or more is unoccupied. And according to Hans' rule, the 6th electron enters the second of those p orbital and with the same spin as the 5th electron. Ano ibig sabihin yan? Okay. So, first, from the atomic number of carbon is equal to 6, we have to distribute that to different energy levels. So, una, again, yung 1s. Next is 2s. Puno, no? Mapuno itong 1s. Puno din itong 2s with 2 electrons as superscripts. And then 6 minus 4 is 2. So, Since after 2s, ang next na ma-fill in ng electron is 2p. So, dito mailagay yung 2. So, again, to check, number of electrons, 2 plus 2 plus 2 is 6. Okay. So, since puno na itong 1s2 and 2s2, hindi na kailangan i-drawing. Ang i-drawing na lang natin dito as orbital square para sa orbital, ang p, subshell. And then we have 2 electrons, then let us draw an arrow, where an arrow represents electron. So again, nasa lower part, the 6th electron, ito yon, 6th electron enters the second of those p orbital. This is the second orbital of p. This is the first, no? So according to Hans' rule, the 6th electron enters the second of those p orbitals and with the same spin as the 5th electron. This is the 5th electron. Magkapareho yung spin. So next is periods. So refer to the horizontal rows of the periodic table. Looking at the periodic table, you will see that the first period contain only the elements hydrogen and helium. So yung row, yung period, yung pag-ano na arrangement. So sa first period, nandoon yung hydrogen at saka dito sa group 8, ang helium. Okay, sa period 1 ito. Period 1. Okay, so this is because the first principal energy level consists of only the S sublevel, and so only 2 electrons are required in order to fill the entire principal energy level. So each time a new principal energy level begins, as with the third element, lithium. So a new period is started on the periodic table. Bakit kaya? Ano pala ang configuration ng lithium? May Z equal to 3 ito. So starting from 1s2 and 2s1. Okay. So this indicates na nasa period 2. Itong coefficient na to, itong 2 na to, is the indicator na nasa period 2 na to, itong lithium. Okay. So next, we have beryllium with Z equal to 4. Okay, so distributing 4 in different sublevels, 1s2 and 2s2. So 2 plus 2 is 4. So again, indicates that beryllium belongs to period 2. Itong 2 na to. Period 2. Next, we have boron with Z equal to 5. So start tayo sa 1s2, 2s2. So 2 plus 2 is 4. 5 minus 4 is 1. So meron pa tayong 2p1. So to check, the number of electron must be the sum of the superscripts. So 2 plus 2 and 1. So again, itong last energy level indicates period, na nasa period 2 ito. Pareho sila. Period 2 or second period. Okay, so we have this electron configuration of second period elements. Starting from lithium, atomic number 3, so we have 1s2 and 2s1. Next is beryllium 4, 1s2 and 2s2. Boron 5, 1s2 2s2, and 2p1. Carbon 6, atomic number 1s2, 2s2, and 2p2. While nitrogen, 7, so 1s2, 2s2, and 2p3. Neon, atomic number 10, 1s2, 2s2, and 2p6. So lahat itong mga elements na to, located sa second period. Isang linya lang yan sila. Isang linya, horizontal, no? Sa periodic table. Second period. So, paano yan malalaman? Kasi yung last na na-fill in ng electron ay nasa 2 na coefficient. Okay. 2. Yung 2 na yan. Meaning, nasa second period. Itong mga elements na to. They differ kasi yung outer electron na. So, sa 2s1 is 1, T2, 2. Ito naman sa boron, 2 plus 1 is 3. 2 plus 2 is 4. 5. 4 plus 2 is 6. 5 plus 2, 7. And 6 plus 2, 8. So, ito namang mga valence electron na to indicates the group number or its family sa periodic table. Group number or family number in the periodic table. So again, itong coefficient na to indicates na nasa second energy level. Now, how do we know how many electrons are in each sublevel? So, how many electrons man? Sa sp, d, and f, may dalawang number of orbitals tayo ha. Number of orbitals. How many orbitals ang nasa S? Isa lang yan, 1. Ang sa P, there are 3. Ang sa D, there are 5. And ang F, there are 7. So we have to multiply that by 2 kasi 2 lang ang electrons na pwedeng malocate doon sa isang orbital. So therefore, maximum electron in S is 2, in P is 6, in D it is 10, and in F 14. Okay, so yan ang answer. So, an atom has the electron configuration of 1s2, 2s2, and 2p5. How many electrons are in that atom? So, just add 2 to 2 and 4 to 5. Therefore, the number of electrons, Z, is equal to 9. Okay, what if we ask pa kung how many electrons on the outer part or the valence electron ng given atom? So, when say valence, hanapin natin yung pinaka-outer level, like 2. So, again, 2 indicates period. And valence electrons are electrons on the outer level. 5 plus 2, it is 7. Marami tayong malalaman by looking at this electron configuration. Malalaman natin ito, kung ano ang location nito sa periodic table. So, ibig sabihin, nasa period 2 at saka nasa group 7. At saka nasa P block ito. Okay. Next, number 3, which element has the electron configuration of 1s2, 2s2, 2p6, and 3s2? Okay. Ano kaya ito? Which element has the balance, has electron configuration of this? No? So, simply add lang natin ito. 2 plus 6 is 8, plus 2, 10, plus 2, 12. So, hanapin ninyo yung atomic number na 12 sa periodic table. And this element is Mg, magnesium. Next is Hans rule. So the last of 3 rules for constructing electron arrangement requires electrons to be placed one at a time in a set of orbitals within the same sublevel. This minimizing the natural repulsive forces that one electron has for another. Hence rule states that orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and that each of the single electrons must have the same spin. For example, we have 2p, 2p3. Okay. So, sa p subshell, meron niyang tatlong orbital. So, gawa tayo ng tatlong squares to represent orbital. And then, i-distribute natin itong 3 electrons. So, the rule is, ma-fill in lahat muna, tig-isa, before pairing. So, in this case, we have 3 unpaired electron. Okay, next is orbital filling diagrams. An orbital filling diagrams is the more visual way to represent the arrangement of all electrons in a particular atom. So in an orbital filling diagram, the individual orbitals are shown in squares. So sa atin square tayo, hindi tayo sa circle. Though merong mga textbook na gumamit ng circle, pag ganun. Okay? So square ang sa atin ha, para uniform tayo. And orbitals within a sublevel are drawn next to each other horizontally. Each sublevel is labeled by its principal energy level and sublevel. Halimbawa, we have boron, carbon, nitrogen, oxygen. So yung boron, Z is 5, so start sa 1s2, 2s2, and 2p1. Dito na naman tayo sa oxygen, 8, 1s2. Next is 2p2. And since 8, so 8 minus 4 is 4. Therefore, sorry, this is S. And 2p4. Okay. So dito tayo mag-focus sa last na napasukan ng electron. Anyway, itong dalawa, mga fully filled man ito. No? So sa 2p1, merong 1 electron. So yan ang arrow na yan. Sa carbon na 2p2, itong dalawang arrows are that 2. Yung 2 na yan. Itong 3 naman, yung 3 arrows, 1, 2, 3. At yung 4, yung 4 arrows. So the rule is that, lagyan muna isa-isa before mag-pairing. So that's the Hans rule. Okay, electrons are indicated by arrows inside a square. An arrow pointing upward indicates one's spin direction, while downward pointing arrows indicate other direction. So the orbital filling diagram for hydrogen, helium, and lithium are shown in the figure. We have the hydrogen. Kasi si hydrogen, meron itong atomic number na 1. Si helium may atomic number na 2. And si lithium may atomic number na 3. So itong 1, 2, and 3 ang i-distribute sa electron configuration and orbital filling. So this is 1s1, 1s2 for helium, and 1s2 for lithium, and 2s1. So, itong 2 na to, yun ng dalawang arrows na yan. 1 is for 1 arrow. 2s para sa isang arrow. So, according to the Aufbau process, sublevels and orbitals are filled with electrons in order of increasing energy. Since the S sublevel consists of just one orbital, the second electron simply pair up with the first electron as in helium. The next element is lithium and necessitates the use of the next available sublevel, that 2s. Okay, so another example, we have this 1s2 and 2s2 and 2p2. Okay, so again, puno ang S, fully filled. So dito sa 2p2, may unpaired electron. Okay, so this is for carbon atom ito. Next is the oxygen, O. We have oxygen is 8 man to. So 2, 4, 5, 6, 7, 8. 1s2, 2s2. Puno itong dalawang S. And then we still have 4. So 4p. 1, 2, 3, 4. So, again, lagyan muna ng tig-isa before mag-partner or before mag-pair up. So, what is Hans' rule? Hans' rule states that orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and that each of the single electron must have the same spin. Is the diagram in figure A and B correct? And explain your answer. Okay, kailangan natin ng diagram. Yan. So you look at our diagram. This is our figure A. Is this diagram correct? Tama ba ito? What do you think? Tama ba yan? Like this. May nag-try. No. Bakit, Aiza? Bakit kaya no? Okay, you look at this part. Ito. Wala tayong na-drawing na example na ganito. Tama? This second arrow must be pointing downward. So yan ang nakamali. So the answer into is not correct. Or correct yung kanina, no. What about number 3? What is this correct? No pa rin. Okay. So, no pa rin. Kasi, may nag-pairing na dito. The rule is, lagyan muna tig-isa yung orbital before mag-pair up. Okay. Walang arrow yung isa. Pero the rule is that lagyan muna isa-isa before mag-pair up, no? Okay, so dito tayo sa Pauli exclusion principle. So when we look at the orbital possibilities for a given atom, we see that there are different arrangement of electrons for each different type of atom. Okay, diretso tayo sa hydrogen. There is no problem since there is only one electron in the hydrogen atom. So 1s1 agad yung hydrogen atom. However, when we get to helium, we see that the first 3 quantum numbers for the 2 electrons are the same. Same energy level, same spherical shape. So this observation leads to Pauli exclusion principle, which states that no two electrons in an atom can have the same set of four quantum numbers. The energy of the electron is specified by the principal angular magnetic quantum numbers. Okay, so we have this again, an orbital filling diagram. Square represent an orbital, arrow for electrons, and with pointing up and down. So with increasing energy, we have 1s2, 2s2, 3s2, okay, 1s2, 2s2, 2p6, mauna si 2p before 3s, 3s2, and 3p6. Okay. When we add the number of electrons, this gives us an atomic number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, kung hahanapin natin ito sa periodic table ang Z equal to 18, that is argon. Okay. Nasa checking of understanding na tayo. So, electrons enters the 4s sublevel before the third sublevel. This is because A, for the 4s orbital has a lower energy. B, there is only one 4s orbital and there are 5 3D orbitals. C, 4s orbital is spherical, and D, 3D orbitals have a lower energy. So, ano kaya ang answer dito? So, the answer is that 4s has lower energy than 3D sublevel. A ang answer. Next, a carbon atom has 6 electrons, 4 of which are in the outer shell of the atom. Okay, so pwede yan i-check, no? Z equal to 6. So start from 1s2, 2s2, and 2p6. Okay, so 6 naman yan. So 2p2. 2 plus 2 and plus 2 is 6. So sabi dito, 4 of which are in the outer shell. 4 daw. So add natin itong 2 plus 2. I-check natin kung 4 ba yan. Okay, 4 yan. Meaning the answer is true. Okay, for our lesson summary, quantum numbers describe the location of an electron in an atom. There are 4 quantum numbers: the principal quantum number, angular momentum quantum number, magnetic quantum number, and spin quantum number. Aufbau principle gives the order of electron filling in an atom. It can be used to describe the location and energy levels of an electron in a given atom. Electron configuration notation simplifies the indication of where electrons are located in a specific atom. And superscripts are used to indicate the number of electrons in a given sublevel. Hence rule specifies the order of electron filling within a set of orbitals. An orbital filling diagram are a way of indicating electron location in orbitals, where this is a visual way to represent the arrangement of all the electrons in a particular atom. And Pauli exclusion principle specifies limits on how identical quantum numbers can be for 2 electrons in the same atom. So no 2 electrons in an atom can have the same set of 4 quantum numbers. Okay, so that's all for today. I would like to say thank you so much for attending this virtual class.